So, good evening, everyone. I am Rakhi Yadav, your PMRF teaching assistant for Reagents and Organic Synthesis course, which is conducted by NPTEL and whose course instructor is Professor Subhash Chandra Pam. So, students, if you recall, in week 1, we have covered oxidizing agents, right? Whenever you will watch my video, just revise with this. So, students, in week 1, we have covered oxidizing agents based on chromium, whatever all PCC, PDC, PDC in DMF behaves like other way, PDC in DCM changes alcohol to aldehyde only, Babler's oxidation, so we have covered chromium, followed by CAN oxidation, followed by DDQ, which usually take hydride, and is there someone in the class? Yes. Mansi, can you hear me? Uh,
Yes, ma'am.
Okay, thank you. And my slides are visible, right? Okay. So what I was saying that in week 1 we have covered oxidizing agents based on chromium, CAN, DDQ. Okay. And week 2, which type of oxidizing agents we have covered? And in week 3 we have covered reducing agents, right? In this week also we will cover reducing agents based on aluminium and boron. Sorry for my voice. Actually, I am having cold, so my voice is breaking actually. So, I hope you have taken Sir's lecture. So, first problem for today's session is you have this lactone, and I am saying you are given only one equivalent of dibyl H. Now, could you please guess what will be the product? Bache, could you please tell me what can be the possible product? You think over this. Till then, I let me show you some mechanism. Dibyl H. What is the full form of dibyl H? Can you tell me? Di iso butyl aluminium hydride, right? If you draw its structure, it is like aluminium 1, 2, 3, 4, right? And 1 is hydride. But this compound, students, don't remain in this form, it exists in its dimer form, right? So you know that aluminium is from which family? Boron? Yes or no? And you all know that this family have 6 valence electron. Okay. So in order to be stable, it needs 2 more electron. Yes. So it behaves as Lewis acid. And in chemistry, weak wants to go to poor and poor wants to go to richer and rich people wants to go to poor. So it is Lewis acid. It wants to accept some lone pair. So who can give its lone pair? I will not tell about this. Let's have a simple molecule in your hand. One is your acid, one is your let's say keto. Okay, it is having lone pair. Now I will ask you a very basic question. Student, I will be very happy if you take part actively. No issue if you are wrong. Please try to answer by unmuting yourself. Okay. So I want to ask student if this is Lewis acid, this. Okay. Aluminium wants to go to which oxygen? Oxygen 1 or oxygen 2? And why? Which oxygen is more ready to donate to aluminium? Which can easily donate its lone pair? Not donate, or we can say that coordinate. Any guesses among 1 and 2? I hope you are not writing in comment box because I can't see that. Okay. So what I was explaining that I was asking among these two oxygen which is more Lewis basic. Now you should remember this fact that according to Lewis acid base theory, anything which can donate its pair, anything which can donate its lone pair is Lewis basic. Anything which can accept its lone pair, it is Lewis acid. So in our case, student, aluminium is what? You mute, you just pause this video and write in comment section of YouTube that among our reacting reagents, what is Lewis acid and what is Lewis base. Okay, let me tell you, this carbonyl oxygen is acting here as a Lewis base. Okay, and aluminium is Lewis acid. So you should know, I'm expecting from you that you should know oxygen 1 is more Lewis basic. Why? Because this is helping in a mesomeric fashion, right? It is more electron rich oxygen, so it will bind. Therefore, if you take for example, let's say sodium borohydride, your reactivity of carbonyl is like this: aldehyde, ketone, ester, acid, amide. Okay, but if you take double H, your reactivity becomes reverse: amide, acid, ester, ketone aldehyde. And reason behind this is because students, sodium borohydride is your nucleophilic hydride source. It delivers H negative. Okay, so it delivers H negative to the carbonyl, which is most electron deficient. And we all know that carbonyl of aldehyde is most reactive, because here methyl hyperconjugation, here ester OMe group exerts its plus M effect, OH and NH2. Basically, they reduce the electrophilicity of your carbonyl. But here, student, in dimer H, you have acid. First, it coordinates. Okay. First, it coordinate isobutyl H. If it coordinates, oxygen will be having positive charge. It has activated your carbonyl, right? Now, now you all know that as soon as aluminum have four bone, now it have curiosity to reduce that charge. And how it can reduce that charge? By delivering hydride. And in this way, first it forms Lewis acid base complex OAl isobutyl, and here it transfers hydride. And after that hydrolysis, you get the product. So I hope mechanism of dimer H is clear to everyone. Yes or no? Okay. If it is clear, can you tell me now the product of it? So, students, as I have instructed at the beginning of this question, that only one equivalent of dimer H is there. So, it will be, the correct answer is your lactol. Okay. So, this is your product. I hope it is clear to you. Shall we move ahead? Okay. So, second question for today's session is, you have all these functionalities BH3 THF. So, if you are doing this question in your normal college level exams, think what functionalities are there in your molecule. So, if you look at this is nothing but your amide, right? And this is your ester. Now, in previous slide only, I have told you mechanism how electrophilic reducing agents behave. Step 1, coordinate to carbonyl oxygen. Step 2, delivers hydride to it. Okay. Now, student, you know that among wait. Now, students, you know that BH3 is BH3 is electrophilic. Why? It is having 6 electron. So my first question, to which carbonyl it will go? Let's say this BH3 is a person who lives in slum area. It is that much poor. Okay. And you have amide You have ester. Both are rich in their own way, but amide is rich in a way that it is Ambani. In terms of electron can be directly related to money of us. Ester is also rich, but lesser than Ambani. So, which personality can I write here? For example, us. We are not that much rich, but lesser than Ambani. So, obviously, if this person has to take some help, it will go to Amide. Yes or no? It will not come to us. Given an option, it will go to Ambani only. So that's why here I have answered. So its correct answer will be amide will be reducing. So this is the product. Let me rewrite here. Everything will be intact. Okay. I hope this question is clear to everyone. So here comes next reagent, that is your famous Kore Bakshi Shibata catalyst. So students, how it functions actually, let me show you. If this bond is wedge, obviously this hydrogen will be at dash. Now one thing that you should know, if hydrogen is dash is it is, if hydrogen is at dash, it is S, hydrogen is at wedge. But why should we remember all this thing? We have things other than this to remember, right? So you can check the configuration here. How? First priority will be obviously nitrogen. Second will be this. Third will be this. One, two, three. It is anti-clockwise and hydrogen is a dash, so it is S only. Now, how to do? I will tell you the simple way. Simple way. Go step by step. Just do in a way I am telling to you. Okay. You will never be trapped in these questions. What is that? First, check R and S of CBS catalyst. Okay. Then then you should know how to see re and psi phase of your ketone. Go step by step. You will never fail in this. For example, if this is your ketone, okay, you know that obviously how to give its nomenclature. If we are here, first priority will always be carbonyl, second is this, third is this. Clockwise means rephase. Clockwise means rephase, and psi phase means anti-clockwise. This is not mnemonic, this is nomenclature. You have to learn it. If it is going clockwise, and priorities you have to decide by same your Kahn and Prikold rule. Okay. Till here, I hope everything is clear. First, you have to see whether your CBS catalyst is R or S, and second is you have to decide whether your ketone is having rephase or psi phase. Okay? Yes or no? Okay. If this is clear, now the mnemonics part come. Mnemonic means trick. Let me take another color for that. Here is your catalyst. Here is your ketone, and here is your delivery of hydride. So always remember, student, if your catalyst is S and you are having psi phase, it will be hydride will come from above phase, means from wedge. Okay. If your catalyst is again S but your ketone is rephase, it will be down. If your catalyst is R, if your C, if your catalyst is R and ketone is psi phase, again down. If your catalyst is S, ketone is sorry, if your catalyst is R and your ketone is also rephase, then it will be upper. Now, what conclusion can you draw from here that same things, same things lead to delivery of hydrogen from above, okay, and different down. Clear? If everything is clear, pause this video and tell me the correct answer. Before checking the answer, you have to write correct answer in comment box that if you are treating this 2-bromocyclohexanone with this catalyst, what will be your product? Till then, let me explain its mechanism. Okay, that is also crucial. Which part can I? Okay, let me erase this part. But it is can't be erased. Okay, no issue. What happens, student? This is your BH3. Okay, okay. BH3 is Lewis acid or base? BH3 is your Lewis acid. Obviously, it will go to boron. H, H, H. So one thing is clear, your hydride will be coming from these BH3. Now why there is this boron? What is the function of this? Student, actually this coordinates with your carbonyl. Beautifully designed catalyst. This coordinates with your carbonyl to activate it, right? So, and if you see the face of it, one, two, three, okay, this is nothing but your rephase as it is going in clockwise direction. Rephase catalyst is S. Both are different. R ka S, not RR or SS. So hydride will be coming from down. So this is your answer. I hope it is clear to each one who is listening my video right now or later. If still you have any doubt, you can ask me in comment section. Okay? Okay, answer is here as well. Let me erase some part of it. I don't know why it is not. I'm not able to erase that part. Let me again explain you the Kore Bakshi Shibata catalyst. At the end of this practice solving session, I will give you sample problems on this only. So, step one is you have to check whether your CBS catalyst is of R configuration or S configuration. Very easy. Okay. Then you have to see your ketone is of re phase or psi phase. Okay. How to give this re and psi nomenclature, that also I have told you briefly, but I have told you. Mnemonics is if both the things are same, SSRR, hydride will come from above phase. If both things are different, hydride will be from down phase. Nothing else in this stereo of Kore Bakshi Shibata catalyst. This is your borane based reducing reagents, which are used for conversion of ketones to chiral alcohols. See, 96% EE. Now, homework for you guys is if 96% EE, how much is R and how much is your S enantiomer present in this mixture? Okay. I want answer to this question from everyone you. This is not part of this course, but being an organic chemist, you should know this. Okay. Next problem for you students is you have this keto alcohol, you have hydrazine NH2NH2 in this solvent. What will be your answer? Take 30 seconds time and tell me the correct answer. I hope you have solved. It's very easy question. If you remember, this is nothing but your Wolff-Kishnar reduction. If I ask you the direct function of this, converts ketones or aldehydes to alkanes. So the product will be this. Now you will ask me, ma'am, could you please tell us the mechanism? So here is the mechanism. First, hydrazine hydrate will form hydrazone on reaction of this ketone and hydrazine. Okay, it will become C double bond and NH2. Clear? Now you know that uh, base is there. Okay. So in presence of base what do actually? Base will abstract proton from this NH2. Okay, it will become NH negative. This negative will come back and leave here a negative charge. Again one proton is there, base will abstract that, again come, and nitrogen will leave, leaving behind here carb anion. Obviously carb anion will be quenched by, or it will be a proton will come here, it will take proton from water and you will be getting this alkane. So anywhere, if you want to deoxygen, if you want to do deoxygenation, you want to remove your oxygen, you have to use Wolff-Kishner reduction. Now whenever you will see this video, I want to ask, what would be your option for doing the same, but if let's say in that same compound you have some base sensitive groups, then what reagent will you use for the reduction of that carbon to alkane? Okay, I want this answer from your side. You can answer this in YouTube. Okay, very good problem. Take 30-second time and tell me the product. How you will initiate this question? Shall I solve for you? Okay. See, students, it is your alpha beta unsaturated. Oh my god, sorry. Oh, please don't look at the solution part. So, first, it will become your hydrazone. No issue. Okay. You assume that here KOH is also there. What I can do here actually? Student, if it is there, if base is there, obviously one H will be abstracted, this negative charge will go here, and this negative charge will come here, and this will come here, right? Sorry. Negative charge will be here. Clear. This will be quenched in presence of water. Okay, now what you will do? Again, it will abstract proton, yeah? Yes or no? Can anyone tell me what will be the next step now? If you look at its solution, they are forming this first. So, can anyone tell me what mistake we have made, or I can say I have made? Our first step was correct. Base is not there actually. I misunderstood this problem. Okay. Let me rewrite solution here. Actually, I have not seen the functionality. Double bond and NH2. Okay. See, base is not there. Now you can do 1,4 addition here. 1, 2, 3, 4, 5. Okay. N and H. Is this the product right now? Yes or no? Again, what can happen? This can isomerize to this. Now, what will happen, students? This bond will go here, or I can say this bond will come here, this will go there, nitrogen will leave, and you will get this cyclopropane. Is it clear to you? You draw the arrow pushing mechanism, you will get answer of this. Okay. Next question. What will be the outcome if you have epoxy ketone? Answer is this allylic alcohol. It is very easy question. Let's see the solution of this as well. I will not draw this part, okay, as it is going to remain intact here. Double bond and NH2. One hydrogen I am abstracting by this, okay, presence of base. It will go here, this will go here, and open this ring, okay. What you will get? See, epoxide is at below side, okay. So after opening also it will be below only. Yes or no? Again base is there. This bond will come here, N2 will liberate, and you will, and that will be quenched by water, your alkoxy ion, and you will be getting allylic alcohol. You should know its mechanism, but you can write a note whenever you are having alpha beta epoxy ketone in presence of Wolff-Kishner reduction, it gives you allylic alcohol, right? Yes or no? Okay. So till here, I hope everything is crystal clear. Now let's have a look at reactions of diamide. So students, this N2H2, diamide is your N2H2. If you ask me to draw its structure, it will be like this, N2H2. Now this molecule is very unstable. So examiner will never ask you question that you have this substrate and on arrow he will write N2H2. No, it will never write. It will give you something like that on arrow tosyl NH2 heat or this complex. So for this reagent you have to anyhow you have to remember how to prepare this in situ. Actually this diamide forms in situ. In situ means in reaction only. So there are three preparation of this. You should remember this. If NH2 NH2 is reacted with O2 or any oxidizing agent, you will get this diamide, right? Basically, you are oxidizing this hydrazine, okay? And if you have tosyl NHNH2, this again will undergo oxidation, and if you have a molecule like this, it will again go reaction to form your diamide. So, take home message from this slide is that you should know all these three preparation of diamide. Now you have to tell me the mechanism for conversion of third, this N double bond N to imide. Now key features of this reagent. Suitable for reducing symmetrical double bonds. how they want to convey this. Let me tell you. Let's say you are having ketone and you are having this olefin. Let's say you are having this ketone and you are having this olefin, right? So what is the first point of this reagent? It is suitable for reducing your symmetrical double bonds. Okay. This double bond is between carbon and carbon, and this is between carbon and oxygen. So this is symmetrical. So first point say olefin will be selectively reduced in presence of diamide, then carbon. Okay. Reduces isolated double bonds and they should be less sterically hindered. If you keep second point in your mind, can anyone tell me what will be the product of sorry. Can anyone tell me the product of this on arrow? It is nothing but preparation of in situ diamide. Now can you explain me what will be the product? Take 30-second time and do it. See, this bond is actually it is having long range resonance only, but this bond, if you see, look at here, this bond is in conjugation with this system more than this is involved, right? So obviously this bond will reduce. You have to select between, see, this carbonyl is ruled out among rule number 1, that you have to reduce symmetrical double bonds. Okay. Now there are remaining two olefins. So only good option is this, right? So the answer to first question is we have already solved. Can anyone tell me among first and amongst, oh my god, answer is written. Still tell me among olefin 1 and 2 which will be reduced selectively. Okay. If you see the third point of this reagent, what it is saying that more strained double bonds react at accelerated rates. Okay. If you look at this ring system, can't you see this bond will be quite strained? So students, here E will be selectively reduced in presence of Z alkene. Okay. So the correct answer is you will reduce this part. Okay. Why? Because it is more strained. That's why. Now, keeping same point in mind in one go, can anyone tell me answer to this? And third question people have asked in competitive exam. And on arrow you can see that on all the three arrows diamide is written nowhere, right? You are given precursor of that because diamide is student unstable compound. you have to prepare it. Okay, and for preparation of that, you should know all the three procedures. If I recall you, one is your hydrogen hydrate in presence of any oxidizing agent. You know O2 is oxidizing agent, H2O2, copper in second oxidation state. Second method is in presence of heating, tosyl NH2. Okay, tosyl H will be removing, and you can get diamide. And in third, and this can be called a diazo compound, which in presence of acetic acid can give you diamide. So this you have to memorize it, okay? And if you know everything, tell me the correct answer to problem number third of this page. Okay, let me give you options. This is your olefin 1, 2, 3. Options 1, 1 and 3, 3, 2. Write your answer in comment box, then see the solution. Okay, this is chocolate question for a person who is watching my YouTube videos on this. So student, this is your Z olefin, this is your E olefin. Okay, and we all know very well that E olefins are selectively reduced in presence of Z. So the correct answer for this is option number B. Correct. Okay, if you want to write in chat box, it is problem time. You can write it in like this: problem time. Question number third and your answer. Okay, good, very good. Now two more problems on this diamide. Then your diamide part will be clear. If this question will be asked in your exams, your college level exams, or in your competitive exams, you should keep three things importantly in your mind. First, you should know all the three procedures to make diamide. Okay, what are they? First is hydrazine in presence of any oxidizing agent. Second is your tosyl NH2 in presence of heating condition will give you diamide. And third one is your students, that N double bond N CO2K CO2K. K actually that is dipotassium salt of carboxylic acids. Okay, and in presence of acetic acid it will give you diamide. Okay, so first thing is you should know the procedure. Second, you should know the key features of this reagent because it is very selective. It is not like your LiLH4 which goes with everything. Okay, the person which goes with everything has less value in market. Yes or no? So this is quite selective, therefore it is famous. Okay. So first point of diamide reduction was, if I write in bullet points, symmetrical double bonds over unsymmetrical. Second point is, can anyone tell me? First point is symmetrical double bonds will be reduced in presence of unsymmetrical. Then sterically less hindered than your hindered one. Isolated than your conjugated one. If you know these things for this, you can never miss question on this topic. Now, for this part, let me number 1, 2, 3. Now tell me among these three numbered olefins, which one will be your most reactive for this reagent? And the correct answer is option number 3. It is disubstituted, disubstituted. It is monosubstituted, monosubstituted. So monosubstituted olefins come ahead of your disubstitution, that is due to sterics. Now this question is very good because it involves stereo. So I want question to this in terms of stereo. See, this reagent doesn't like steric hindrance in any case. Okay. So in this structure you have two phase. At I think in my first lecture I've explained how you have to imagine this. Let me give you again a rough picture to this. This is like this, students. Okay, and if you take these two pens, they are in like this. So this is like this. Okay, in two opposite ends, the pen will be like this. So if you look at this structure and if you imagined it well, now there are two sides. One is this above side where your central of your notebook are connected. Okay, corners are connected in this. And third one is where your notebook, this side is there. This side here you are having two carbons, one and two. But here you are having one atom, and that too is oxygen, devoid of any substituent. Okay, so obviously your hydrogen will come from above side. Okay, if hydro here it doesn't matter, but here it is chiral center, so your hydrogen will come from above side. In this way, you have to decide stereochemistry. Correct? I hope you understood. Yes or no? Yeah, the product is here. So this is your correct. So this is the problem of diamide which have stereo connected to it. Okay. Now next topic, students, reactions of trialkyl silanes. Now let me give you a brief example first, then we will look at this topic. Trialkyl silanes. Silane is nothing but your H. Oh my God, sorry. R. Basically, their function, student, is to again give hydride. It is source of H minus. Okay. Now, if you look at this, BF3 ethyrate is your Lewis. Okay, which type of acid is this? Is it Lewis acid? Is it Bronsted acid? It is your Lewis acid. Okay. This is a DCM solvent, source of hydride. If anywhere you see trialkyl silanes, it is nothing but source of hydride. Okay. So Lewis acid will coordinate to which oxygen? Obviously to it can coordinate with other as well, but from here it will be entropically favored. This oxygen lone pair will push and knock off this OH group. Okay. What you will be getting, I will not draw the other part. I will just draw where changes are happening. O positive. Now hydride will be coming from this side and you will get this compound. So basically what you have seen here is it can knock off hydroxyl groups. Correct? Okay. If everything is too clear, can you tell me? Okay, mechanism is already given on this slide. I should have this. See, student, this oxygen lone pair is there. Basically, this R is your aryl group. Okay, so this vinyl cation will be stable here due to presence of this R group. Okay, it will attack here, and what you will get? You will get intermediate like this. Okay. Now what we'll do in presence of acid, again this oxygen lone pair will go here and this will be here, and this negative charge will abstract proton, and you will get this oxonium species. At last this triethylene hydride will be attacking onto this oxonium, and you will get this 5 membered ring. This is actually from our lab group only. We generally use this in our lab. We used to do reductive hydroalkoxylation, reductive hydroamination. Why reductive? Because at last you are reducing something, okay? And like here in this case, we are reducing oxonium, right? Yes, sir. Okay. If everything is too clear, this question is very easy, but with the combination of this question is easy, but with your combination of some other reagents as well. So, what will be the first step in after A? Okay, this option is students having OH. There are two functionalities. One is your amide. This is your okay. Now it is not working actually. Tell me. Huh. This is your amide. Okay. Oh, due to this, this is your amide functionality. This is your aldehyde. Carbonyl of amide is more Lewis basic. It is Lewis acidic. It will coordinate with this and convert into amine. So if it is amine, which two option we can delete directly? This one and this one. You can directly delete these two options. See, in competitive exam student, you need not to know every concept. Okay, let's say in one question, three things have been asked to you. If among that three things you know one thing, na, it can eliminate other options. Okay, so in competitive exam, keep yourself alert. Look at the options clearly. Look at the question what has been asked to you. Okay, so these two. Oh, sorry. Second is your elide, PPH3. This is your elide, okay. And you know that this is nothing but your Wittig reaction. In Wittig reaction, this phosphorylide react with your, if I write it R group, RCOH, okay. What it will be? R C double bond O Now comes, okay, now tell me, uh, is it stabilized elide or unstabilized elide? This also I have covered in previous week's lecture. Anything, student, anything which can make this carbanion stable is stabilized elide. For example, here, this is your stabilized elide or not? No, because this is having plus M effect, this is having plus H effect. It can't it can't stable this carbon ion. Okay, so here you why you should know that it will be stabilized or unstabilized, because on that basis you have to give it stereo. Here stereo doesn't play a role because in last step it is getting it is undergoing acidic hydrolysis. But still, but still you should know, okay, that okay. Now you know that Z olefin. Obviously in aldehyde this group will be having more priority one. So this, in order to make Z olefin, other priority should be this side only, and that is your OCH3. So this is your Z olefin, correct? Now in presence of acid, it will undergo like this, and you will be getting what? R. R is nothing but this group, devoid of oxygen, right? And then you are getting RCCOMe. Here it is aldehyde, here it is COM. This M, which you got from this Wittig reagent. Okay, I hope it is clear to everyone. So the correct answer is option number C. That's why I always ask to you, if you want to become master in reagent chemistry, you should know the other part of organic chemistry. Okay, good. So here is most awaited reaction, that is your clemmenson reduction reaction. What it does actually? Okay, tell me, is this a acid sensitive group? Can this HCl is enough acidic to protonate this and substitute it with Cl? No. So this OH will be intact. So only one option is there. And you know that Wolff-Kishner and Clemmenson reduction reduces carbonyl to alcohol. So correct answer is option number C. I think this is last question for today's session. Then students, we will revise some concepts which are a bit difficult for you to understand. Okay. Before that, uh, the last question is, let me read for you. Correct sequence of reagents carried, but correct sequence of reagents carried for the, okay, here instead of but it, here it will come for the following conversion is R. Let me tell you in starting only, this is MSQ, multiple select question. More than one answer can be correct. So you take not 30 minutes, 30-second time, and give me the answer for this. So see, you have to look at option and see, do you know the every reagent? Yes, you know each of the reagent. You know BH3, you know dibel H. Last one is nothing but your what Wittig reagent. Okay, okay, go. Do one by one. Is there anyone in class right now? I can do with the help of that person. Okay, no. Okay, let us start solving this. Okay, in option number A, first reagent is your BH3THF. This is ester student. This is amide. So same funda I have been explaining from slide 1. Electrophilic, it will go to this Ambani type person, and in first what you will get, let me draw for you. Good. Okay. I hope you know the mechanism why amide goes to amine. Let's say if it delivers hydrogen here also. This nitrogen lone pair will push and again OH will knock off. Then it will reduce that imine. Okay? Okay. And at last what is given is CH2 double bond PPH3. Okay. But student, you all know very well that. Okay. This product you get after in first option after A. Sorry, A to the first part. Now they are adding double H. Student, if not given, always consider one equivalent of double H. Okay, I'm telling this for your competitive exam point of view. Ester will be first converting into aldehyde. I hope I don't. I should not tell you mechanism, or should I tell you? Coordination of this oxygen with aluminium, delivery of hydride will come back, knock off this OM. It will result into aldehyde. And you will get this aldehyde. Okay, now Wittig, unstabilized alide. Okay, this will be the product, and yeah, you want this only. So option number A is exactly correct. Now, can anyone solve option number B? Okay, let me solve option number B with a different color pen, black. Okay. LiBH4. If you remember my previous slide in LiBH4 column, I have written it loves ester. So first love is ester only. Loves ester means it will reduce ester. Okay. It can't reduce amide due to its low reactivity than that. So you will be getting CH2OH. Clear? It can reduce your ester to alcohol. Okay. Now they are saying BH3THF. You very well know that in BH3TH student, it is very good problem. I will recommend you, please solve this problem by yourself. You will be having confidence then. Okay. Now they are saying PCC. Okay. PCC will lead to formation of aldehyde and at last Wittig. But one problem is there, it will be CH2 only. Okay. So after Wittig, you will get this product. Sorry, this. So option number B is also correct. Now let's move to option number C. Okay, LiLH. Student, you very well know that LiLH4 can reduce everything under the sun. This point also I have written in that slide. I hope you are, since you are not in class, I'm expecting you are watching these videos and lecture slides after the in your free time. I'm hoping that. Okay, so you make this alcohol in presence of PCC, it will undergo oxidation and again it will give you the same product, which is this in BT condition. So option number C is also correct. Last but not the least, BH3THF. Okay. So in BH3, okay, let me change the color. It will reduce selectively amide and keep ester intact. Okay, then NaOH2O. Okay, okay. It will lead to basic hydrolysis. Basically, it will make it acid. Okay. CH2N2. But CH2N2 it will lead to formation of COOCH. Okay. So option number D is absolutely wrong, students. The correct answer for this problem is ABC. I hope you are not having any problem in this question. Still, if you have any doubt, you can ask me in comment section of YouTube, or I have given my contact number also. You can ask me on WhatsApp. Okay. So this is all for today's session. Now let me revise whatever I have. Okay. Uh, so students, in today's class, I have started with double H. I have started with reducing reagents based on aluminium, zinc. Okay. So in today's class, I have started with double H and I have told the mechanism. It is electrophilic hydride source. It first coordinates with carbonyl or oxygen, then it delivers hydride. So basically, read deciding step is to which carbonyl it will bind. Okay, so you all know that in double H, oxygen, which oxygen is more Lewis basic. If you look at two options, here I have made the same but they are different, student. One is your carbonyl of acid and another is your carbonyl of aldehyde. Okay, so more basic oxygen is your carbonyl oxygen, then your aldehyde. So first aluminum will bind to this and it will give hydride. Therefore in double H, order of reactivity is amide, acid, ester, ketone, then aldehyde. Okay. After that, we have covered BH3 based reagent. It is sort of that its reactivity is similar to a double H, but here borane has been used. Okay, BH3 is not stable, therefore it is it is in form it is form complex with your THF molecules, right? So if you look at the starting material, it is having two functionalities. One is your amide, another is your ester. Okay. So what I have told you today in class is that in chemistry, plus wants to go to negative and negative wants to go positive. Basically opposite attracts. So BH3 is electron wise poor, right? So among these two oxygen, which carbonyl is more Lewis basic? Amide carbonyl. Therefore, what it will do is it will coordinate to oxygen of amide, deliver here hydride, it become an OH. Nitrogen lone pair will push, knock off that OH. Again, iminium ion will form and it will reduce that to amine. So amide changes to amine in presence of any reducing agent. Okay, so good. After that, student, we have covered most important topic of today's session is we have seen how to decide stereochemistry of Kore-Bakshi-Shibata catalyst. That is your CBS reduction catalyst. Student, if you remember this slide, you will never do wrong questions related to this topic. Okay. So this is your oxaborolidine complex. It is having nitrogen and boron. You know that nitrogen is Lewis basic. It will coordinate to BH3 like this. If boron family have four bonds, it has tendency to have negative charge on it. Okay. Now your boron is free. That ring boron, right? It coordinates to your carbonyl and increases its reactivity, and this BH3 delivers hydride in that way. Now, how to decide stereo? What I have explained you to decide stereo, students. First, you have to see whether your CBS catalyst is R or S. One thing is you can memorize that if hydrogen is at dash, it is your S CBS catalyst. If hydrogen is at wedge, it is your R. But why to give risk to this? It's always better to find R and S of this catalyst. Okay. So first task, find R and S nomenclature of your CBS catalyst. Second, you have to decide re and psi phase of your ketone. Your ketone is having re phase or psi phase. For that, I have told you already. Always first priority will be your ketone. Then among these two, obviously this will be higher priority as it is having 3 chlorine. So 2 3. Clockwise rotation, rephase, and let's say if CCl3 group is in left side, it will be of psi phase. So two things. First determine stereo of your CBS catalyst and then re and psi phase of your ketone. Right? Okay. Then comes how you will give stereo now. Now I was saying if it is RR or SS, same, then hydride will be coming from above side, and if it is RS or SR, hydride will come from downside. See, catalyst S CBS, ketone is of your psi phase, hydride is coming from above. Similarly, RR above. When they are opposite, it will come from down phase. So this is mnemonic of this catalyst. You can remember, and you can solve any question related to this. Okay, good. After that comes Wolf Krishna reduction, whose function is to convert ketones to alcohol. So first ketone changes to hydrazone in presence of NH2 NH2. Then in presence of base, it will abstract NH2 proton, then that negative charge will come back and leave negative charge or make carb anion, which will be further quenched by your water, right? Sorry for that. Examiner can give you other electrophilic source as well. So that let's say they give R dash Br. So in that case you have R double dash. So in that case you will be getting R dash R double dash. Right. Fifth one is your alpha beta unsaturated ketone. Okay. uh, since base is not there, it will cyclize and N2 will leave and you will be getting this cyclopropane. Again, very interesting problem. Should remember. Then I have asked you if you are given alpha beta epoxy ketone and in on arrow Wolf Kishner reduction condition is there. Hydrazine in presence of base. You directly have to draw allylic alcohol, right? Allylic alcohol. Okay, then most important topic of today's session was that reaction of diamide. So for that, I told you that uh, you should know all the three preparation of diamide. First is hydrazine in presence of any oxidizing agent such as H2O2, O2, or copper in 2 oxidation state. Another is your tosyl hydrazone TSNH2, which in presence of heating give you diamide plus toxic acid. Not toxic acid, that is TSH. Okay, okay. And third one is your this dicarboxylate in presence of acid will give you. Then I have told you the key features of this reagent, that isolated bonds will be reduced selectively among E and Z. E will be reduced selectively, then Z. Okay, and least sterically hindered. Even both the hydrogens will add from same direction. Okay, in diamide, they both the hydrogen attacks in same fashion. Okay, same fashion, so not same. So here, since above side only one oxygen is there, so both the hydrogen will come from there only, right? Okay. Then reactions of trialkyl silanes came. Here I have told you that it is nothing but source of hydride H minus. Okay, in presence of acid, somewhere oxonium will form, and you have to reduce that oxonium via this hydride. In exam, they can ask you. They will first make you imine. They will first, okay, and then you just have to deliver their hydride. So basically, it is another reducing agent. Now your take home homework is, can you tell me in next class why it is eager to deliver H minus? Because if it deliver H minus, positive charge there will be on silicon, and silicon is from carbon family, and 3 alkyl group can stabilize that. And there are some other reasons also which you have to tell me next class. Then though this I have told you very clearly. Okay. Now students comes very interesting question. This topic I want to explain you, then I will ask you question. Is there anyone in class? So that, okay. Now students, let's say you are having this alpha beta unsaturated ketone in your system. Okay. This is question with concept. And on arrow, first I will tell you the basic mechanism, then I will give you problems. Okay. One or two problem I will solve in class. Others will be what will be your homework. Let's say on arrow, first it is written NaBH4, and second it is written CH3 COOH. This is in actually next step. First, okay, this is your N. Okay, now it is clear. And how examiner will make this? It will give you TSNH2, and you will be having same molecule. This you know very well that in presence of hydrazine, your ketone changes to hydrazone. Now, what happened in this case, students? Okay, see, acid is there. A role of acid is to give H plus. Role of sodium borohydride is to give H negative. Now, what will happen? Basically, you know very well that iminium is more reactive than your imine, right? You can't reduce imine at room at pH of 6 to 7. So basically, it is decreasing your pH, making the reaction medium acidic. Okay. So who is making acidic here? Your acetic acid, which is having hydrogen like this. Yes or no? Now nitrogen is having four bonds. It is having plus charge. Now this sodium borohydride will deliver hydride here. NH NHTS, and it transfers hydride. Everything is clear. Now you know one thing is that if this acid protonates this nitrogen, wait, sorry. If this acid protonates your hydrazone, this will be CH3COO negative. This acetate will abstract proton from here. What it will do? This negative charge will go knock off this tosyl, and you will be tosyl H will be removed. Okay, and what you and you are with this compound N double bond NH. Okay. Now you know that student, you are having this N2, and if from your system neutral molecules like SO2, CO2, N2 leaves, it actually increases your entropy. So for some reaction, it is driving force. So here what happens, student? 1,5 sigma drop, 1,5 hydrogen shift take place. For that, let me write it in another form for clear understanding. This is a very important concept, student. That's why I am myself drawing this for you. This will transfer here, this will transfer here, and from here N2 will leave. Right? And basically what happens is, whenever you treat this alpha beta unsaturated ketone with tosyl NH2 and followed by this reaction mixture, you will be having double bond between alpha beta unsaturated ketone between this carbon, if you have observed. Yes or no? Clear? If not, again listen my video and you will be more clear. Okay, let's go to next slide. Now let's say examiner will ask you, and on arrow they write NaBD4 and CH3COOD. Sorry, H. Let's and write here P. Tell them the product P. Can anyone tell me? Okay, let's solve this one by one. One thing is clear, this will protonate it. Okay, now this BD4 means D minus will attack here, and what you will get? Clear? I hope it is clear to everyone that it transfers. Now, though it is very simple, you have to just look at okay. Before that, you have to leave this docilage. Now, one more question will arise in your mind. It is your D. Okay, N H sorry, N double bond NH. Now you may ask, ma'am, one, two, three, four, five. Okay. And you have, okay, here it is clear, it will transfer hydride here. This double bond will shift here and you will get the product. Okay. So, okay, this was last slide. So let me give you homework. And if I have explained it in a good way, I will expect that you come with the solution to this problem in next class. NH, NH, TS, and I am giving you an arrow NaBH4 and CH3C. This is a very good problem. And tell me the product. So, student, this is homework for you for next session. This is very important concept. From alpha beta unsaturated ketone, you can have double bond between those two conjugated ketone, right? So keep this thing in mind. This is all for today's session. So we will meet in next week. So by this class, we have covered both oxidizing agents as well as your reducing agents. Okay. So thank you students for joining the class.